Hi, my name is Martin. My Chinese name is Yong Xie, so you can call me Martin. And I used to work in quantitative hedge fund in London for about 3 years. So, and also I started a fintech company in China, focusing on quantitative trading systems and trading some signals as well. So I come from a quant trading background. I have a PhD in computer science. And I've been using Python, C++ for a long time, and then I switched to Julia, which is the language I'm going to talk about today. And I realized, in quant trading, there has been quantitative hedge fund using Julia already. So, so there's definitely an opportunity for Julia to make a difference in like quantitative trading industry, but also in other industry as well. And so today I'm going to talk about how to use Julia for decentralization. So can I have like a quick poll, like how many people have heard about Julia before? If you yeah, slides. Okay, okay, no problem. So, Julia has been there for more than 10 years. And one thing I normally would ask is how to make Julia into the mainstream, like Python. A lot of industry people use Python. And of course, Julia is also very popular in the scientific computing area, and Julia has proven itself to be the solution to a true language problem. So what I mean by the true language problem is that on the one hand you have data scientists, and they usually do a lot of data analytics and prototype, and they have the domain knowledge. They typically use an easy-to-use language such as Python, okay, or MATLAB or R, and they normally talk to each other. So that's the one side, okay. And on the other side, we have engineers, programmers, developers, who are more focusing on systems. Okay, they try to build systems to extract all the performance from the hardware given inside an organization. So these two are two types of culture, because the engineer, the system people, they typically use like C, C++, which is very sort of lower level, but the performance is very great. Okay, but for data scientists, they use Python, which is easy to use, but the performance is not that great. So we have this two language problem, okay? And typically within an organization, you have to have some mechanism to merge these two, to have some way. First of all, maybe you develop something in Python, and then you translate to in C++, which happens in quantitative hedge funds, let's say 10 years or 15 years ago, okay? But then Julia comes. And Julia is a programming language that is very easy to use, just like Python or MATLAB, but also it's very performant. And it has proven itself in the supercomputing industry, and it has been used in Lawrence Berkeley lab for modeling satellite images and so on. So definitely Julia has the potential to offer much more than what we have seen today in the industry. And what I believe, what most people see is just the syntactic feature or the advantage of Julia. And in fact, Julia, if we can extend Julia or maybe come up with a superset of Julia, we should be able to use it in a decentralized way and to unleash a lot of value in digital transformation for almost all industries. And this is, I think, the most important area that I think currently we can contribute to the community. And also, if we can combine blockchain technology together with Julia, I think there's a lot more things could happen, and a lot better economics could happen. And very fortunately, we are actually developing some packages along this direction, and we are happy to announce we are releasing the first part of a package, and is in this direction. It's using Julia, and if anyone is interested, you can actually contact me after the talk. Okay, so for those who haven't heard about Julia or haven't used Julia before, let me give you a very, very brief introduction of Julia. Julia is a high-level, general-purpose, high-performance, cross-platform dynamic programming languages. And what I mean by high-level is like MATLAB, is like Python. So it's very different from C, C++. It's general purpose. It can work in all kinds of domains, not restricted to like scientific computing, for example. It's high performance. Like I said, its performance is as good as C or C++ or Rust. And it's cross-platform, meaning you can write it once and you can execute on any platform, and you don't have to do this compilation, because it's actually using JIT, just-in-time compiler, which is dynamic. Okay, and Julia was originally developed for scientific computing, numerical computing, and it's open source and under the MIT license, and the four co-founders there. And the paper, if you want to read, is the Julia: A Fresh Approach to Numerical Computing, and currently it is in its 1.9 or 1.10 version, so it's quite stable already. Yeah. Okay, and Julia has several special features that I want to focus on today. I mean, apart from being easy to use, dynamic, and the performance is really great, there are two things that I think differentiates Julia from other programming languages. One is accuracy, the other one is multiple dispatch. And I think these two special features form the foundation to extend Julia to be used in a decentralized programming environment to build decentralized systems. And what I mean by accuracy is that most programming languages today, they are built by computer scientists and pure computer scientists. And but Julia is different. Julia has mathematics built inside at the bottom. Okay. Let me give you some examples. For example, when you want to concatenate two strings, in Python, we would use the plus sign, okay? But in Julia, we use the multiply, the star, okay? The difference is that plus is commutative, okay? You can swap the position of the two numbers, and it will give you the same number result. But if you do multiplication, it will be different. Okay, two matrix, when they multiply, if you swap the position, it's completely different. So in this case, we should use, because for string concatenation, we shouldn't swap the position. Okay, so the multiply or the star sign is actually, I mean, mathematically, is more appropriate. Okay, and for some basic statistics packages, for example, the default degree of freedom for calculating standard deviation in Julia is using n-1, but in Python it's actually n. Okay, and Julia also takes special care with approximation. Okay, when you do big numerical computation, so you want to be very, very careful with, because when you do functional composition, and I mean, all kinds of numerical errors could happen, okay? So Julia is very, very careful with this. And Unicode support also is very useful, because sometimes when you want to translate some mathematical formula, algorithm into programming languages, and well, if you have this Unicode support, well, the code is is the math. Math is the code. Okay, so that's very good for working with scientists, working with engineers. So this is very good feature. Okay, and what's even more important, especially in the recent LLM AI trend, is that accuracy actually plays an even bigger role. It's not just just to avoid numerical error. It actually influence or has a big part in how you can achieve a bigger LLM. Because for example, if you look at go back to history, at the beginning, people are using FP32, which is a floating point single precision. But in numerical computing, in scientific computing, most people would use 64 bits. But because in LLM you want to have much bigger models with billions of parameters, so you have to keep in consideration the memory footprint. Okay. And also the GPUs, for example, at the beginning, most people are using NVIDIA, graphics GPU for training, and those GPUs are specifically tuned or optimized for sort of lower precision arithmetics, for example, single precision, 32 bits. So in this, and also people in the AI industry also come up with FP16 mixed, which is sort of trying to reduce the memory footprint and also reduce the calculation as much as possible, just to try to accommodate bigger LLM models. Okay, and so they all this kind of research in the end becomes trying to keep a balance between memory footprint, or the training, fine-tuning, inference speed, and also the prediction error. So I think Julia has a very promising future in this regard, because as we have seen, most of the big giants in the AI industry, they are producing specialized chips. For example, Google has TPU, Amazon has its own chips, and Apple has its own chips. Microsoft also unveiling its own machine learning or AI chips. So all of this are going to have very different characteristics in terms of their hardware. In fact, the BF16 format, which is specialized 16-bit floating point formats proposed by Google, I would believe that hardware, but may not be working the same performance in other companies' chips. So we have seen all these kind of heterogeneous. We are seeing heterogeneous type of computing platforms, hardwares, and in order for any software to be able to run on this type of hardwares, you have to be very flexible. You have to be able to deal with this floating point accuracy very carefully. Okay, and in addition, if let's say you have a decentralized environment, for example, some company build like part of the model, okay, maybe trained some model, and then need share with some other agent, some other organization, and trying to do something more. And then during this process, so although everything was tested in one organization, which is absolutely fine, but when you have two organizations trying to collaborate with each other, things could go wrong, because during this composition, a lot of this hidden sort of numerical errors could happen. So that's where I think Julia will shine. Okay, and the way how Julia resolve this kind of issue is using something called a multiple dispatch. And in short, multiple dispatch decouples the attributes and the methods in object-oriented programming. And you can use struct, which is corresponds to attributes, and function corresponds to method, by anyone, written by anyone, anywhere, at any time. But they can be run together or independently in any application. Okay, and this allows total transparency and full control, full user control. And this lays the foundation for decentralized composition as well. And I'm going to illustrate this with an example. You see here we have a toy example for tennis players, and we have an abstract type which is called tennis player, and this is like the higher sort of abstract parent class or parent type. Depends on how you call it. And then you have subtype, which is, let's say we have 3 here: Federer, Nadal, and Djokovic. Okay, they are all subtype of the tennis player type. Okay, and just now, by using this, okay, we are able to instantiate. We can create objects already, just based on this struct. Okay, which is not true in object-oriented programming, because in OOP you have to have the object, you have to have the class, which is well-defined attributes with its function to operate on those attributes all together. Okay, but here in Julia you don't have to. You just need the struct. Okay, and then you can instantiate already. And then maybe on a different machine, in a different organization, you can write the function that work on those structs. Okay, so in this case, let's say I write a function called compete, which takes in 2 players. One is, let's say, a Djokovic style. The other one is any player. Okay, and then because Djokovic is currently the GOAT, he has the most number of Grand Slams, so Djokovic wins most of the for most players. Okay, so let's say I have this, I have defined this compete. Now, in your application, in your organization, let's say you don't like this. Your favorite player is actually Federer, and in fact, when Federer was in his prime, he beats Djokovic a lot of times. So you can actually write another compete function that takes in same also 2 players, one Djokovic, which is same, and then a Federer style. Okay, this Federer style is a subtype of the general abstract tennis player. Okay, and in this case, it sort of overrides the default compete function, and then at runtime, the JIT compiler, the Julia compiler, is able to detect the exact parameter type, okay, and is able to output differently to give you this full user control. Okay, so if you run it, let's say we have a Djokovic and a Nadal to compete with each other, Djokovic wins. But since I have override, I have used multiple dispatch here. When we compete, we have a compete between Djokovic and Federer, Federer wins. Okay, so this is called multiple dispatch. It allows user to override any function that's available given to them. Okay, and this can happen at runtime. Okay, so this is something very, very new, and I think this is going to enable a lot of things for all industry. Of course, you may say, so what's the big deal? I mean, in our organization, we have so many developers. We are so efficient. We only use, those big softwares, very famous softwares, and we don't need to do this kind of small modifications. But unfortunately, even for big open source projects, softwares, there are limitations, okay? Because existing open source software or industry is very easy for read and execute, but they are very expensive, or very difficult to write. For example, in a quantitative hedge fund in UK managing about $30 billion US, they were using C++ or C++ for their trading systems. And they have to buy a commercial parallel compiler to compile their trading system. And it's going to take hours, so they have to do it overnight. Okay, so to modify anything, it's not easy. It's definitely not easy. Okay, and an example 2 years ago, in November 2021, called Log4Shell, this vulnerability in a very famous Apache open source project called Log4j actually demonstrated why we actually need multiple dispatch. Okay, because this, of course, you can read the details here. I just give you some brief information. So this vulnerability is very serious and it's the highest severity ranking. It allows remote code execution, and it's very widespread. And it actually affects 93% of all enterprise cloud environments like AWS, Cloudflare, iCloud, Tencent, Alibaba, and so on. And this is not a new bug. It actually existed 10 years ago. Okay, so this kind of the bug exists, but the most serious thing is this. Now, on the right, you can actually see a Twitter message. This is actually published by a Chinese software engineer in Alibaba cloud company. He actually published this bug. He discovered it and he made it public on Twitter on November 24th, 2021. And he notified Apache immediately as well. The first reported exploit, happened 7 days later. And of course, there could be numerous unreported exploits because companies maybe too shy and don't want to lose face and they didn't report it. But the first reported is 7 days afterwards. And it takes 2 weeks for the first official patch from Apache to be released. Unfortunately, the first patch was not satisfactory. There are still bugs. And it took another 9 days to come up with another patch. And then they found two more bugs. So they have to release another bug fix in 3 days. And that wasn't enough. And only until December 28th, which is 30 plus days after it was first published, this bug was finally resolved. Okay, it took more than 30 days. Well, I mean, in some industry, for example, let's see, like e-commerce or maybe some internet company, this is not, so difficult. Maybe their clients could tolerate. But unfortunately, if you are coming from an industry of, let's say, quantum finance, quantum trading, this is unimaginable. This should be impossible. Okay, let me give you an example. In 2012, August 1st, a very famous quantum hedge fund actually doing high-frequency trading ranked top 3 called Knight Capital. They had a bug inside their software. And this bug cost almost $500 million US lost to this company, to the Knight Capital. And it made this Knight Capital bankrupt. And they have to look for emergency funding. And in the end, it was acquired by its competitor. So only 30 minutes was used for a software bug inside a top quantum hedge fund, very famous for high-frequency trading, to collapse. And in fact, in high-frequency trading, people are talking about nanoseconds or microseconds. So 30 minutes is too much. 30 seconds is enough to take down a whole quantitative hedge fund. Okay, it's definitely enough. So when you talk about a software bug that needs to be resolved for more than 30 days, I mean, this is unheard of and impossible in quantitative trading. Definitely something has to change. Okay. So let me give you some background on quant trading for those who never heard about quant trading. So real quantitative trading is actually scientific computing in finance. So we have a lot of data scientists in quant hedge funds. They're doing data analytics, and they come up with mathematical models, and they try to predict the market. Okay, and you can actually differentiate quantitative hedge funds according to the frequency they trade, and also the type of the fund, and also its asset under management. Okay, on the one extreme, you have high frequency, which requires a lot of speed, and on the other hand, you have low frequency, but you could have for trillions of dollars. And recently, we have seen a lot of trends in quantitative hedge fund using tournaments to outsource its R&D. Okay, this is never happened in the past, and also there are fintech companies founded or supported by co-founders of top hedge funds like Renaissance Technology to build a similar type of platform, open source, some software, some data, to allow data scientists to contribute. And not only in quantitative trading industry, for example, for P&G and Novartis, which is in the consumer product industry, in the pharmaceutical industry, people have been using decentralized corporate management, and they call it the unboss movement. Okay, and all of this actually creates opportunity for Julia, or some extension of Julia, to be used and to unleash a lot of value in this type of movement. And I have included some references to books and papers for you to read, and if you are interested. And whenever you talk about decentralized system, and I think most people consider blockchains. In fact, whenever you talk about different organizations or different people trying to collaborate with each other, definitely, blockchain will play a part to, for example, to reach consensus. For example, unfortunately, the current blockchain or cryptocurrency industry has a lot of problem. They have hard fork, very low TPS. It's not scalable. A lot of scams, and their economics is not good because they didn't create much value, and not many real application happened on blockchain till today, despite so much money being invested into this industry. So I see if we could combine blockchain with Julia or some extension of Julia, I think a lot of things could happen and a lot of values can be generated. And so in summary, what we are trying to do here, actually we are actually doing it, is to change the way how software, especially open source, are actually to be developed through decentralized composition. And currently, we are developing a series of packages, and the first package is ready for private evaluation. So if you're interested, you can contact me. And this is the QR code for my linking. And please feel free to get in touch. And if you have any questions, you can send me here or on linking, and you can request for a copy of the software, and we are very happy to hear your feedback. Okay, that's all. Thank you.